All right. Good morning, guys. Good morning, guys. How are you guys? Based on the fact that I noticed some of us still have some issues on SS1 topics, so I'll be looking at dimensions today. So I thought about us looking at dimensions. So you'll be watching a video, though not by me. I was actually looking for the platform to make a video, but I was not I don't have the whole thing I need to use for the video yet, so I just had to download a video that I know it will actually say what I want to actually say to. So have a nice time watching this video, and at the end of this video, at the end of this video, you'll be having an assignment. So just please go to the assignment portal and check out for your assignment, and please do submit your assignment. Have a lovely day. Enjoy.
In this video, we get to look at the dimensions of a physical quantity. Now, the dimensions of a physical quantity are simply there to show how these other quantities, such as volume, acceleration, how all those quantities relate themselves to the three fundamental quantities. In our previous video, we said that the three fundamental quantities are mass, length, and time. Therefore, dimensions of a physical quantity will serve to show how these physical quantities, what we are calling the derived quantities, are related to the fundamental quantities of mass, length, and time. Now, when we are talking about dimensions, this is the symbol for dimensions. And as such, when we are looking at the dimensions of mass, length, and time, we shall represent them like this. The dimensions for mass is capital M. That is how it will be represented. The dimensions for length will be capital L, and then the dimensions for time is capital L. Likewise, is capital T. So likewise also, as we shall be exploring, looking for the dimensions of like acceleration, dimensions of mass, dimensions of velocity, we shall be writing the word velocity there, and we put these brackets outside. Now, this kind of language means that we are looking for the dimensions of velocity. If we can put here dimensions of acceleration, we put these brackets there. These brackets denote that actually we are interested in the dimensions of that physical quantity. So we'll go ahead and demonstrate this. We'll start with looking for the dimensions of area. Now, we know that area is going to be equal to, first of all, the area is length times width. Now, we need to relate these to the three fundamental basic quantities. So, looking for the dimensions of area, it's going to be equal to length, because we are length times width. Now, the width is also a length, because the width, as far as the three physical quantities of mass, length, and time are concerned, this width is also a length. So it means that the dimensions of area are L squared. Those are the dimensions of area. Let's get to velocity. Now, we all know that velocity is the rate of change of displacement. So looking for the dimensions of velocity is going to be equal to displacement divide that by time. So we look for the dimensions of displacement, and what are the dimensions of time? So now displacement is actually a length. According to the three fundamental quantities of mass, length, and time, displacement is a length. So this is going to be L, divide that by the time. This is a basic quantity, which is t. So it means that the dimensions of velocity are L t to the power -1. Those are the dimensions for velocity. Let's look at volume. Now, the dimensions of volume, we know that the dimensions of volume is given by length times width times height. Now, what are the dimensions of length? What are the dimensions of width? The dimensions of height. We know that length is length. Then multiply that by width. Width is also a length. And then also we know that height is also a length. So it means that the dimensions of volume are L cubed. That is how volume relates to the three fundamental quantities of length, mass, and time. We all know the dimensions of acceleration. We know that acceleration is velocity over time, by definition. By definition, we know that acceleration is the rate of change of velocity. So now, what are the dimensions of velocity? The dimensions of velocity are Lt to the power negative 1. We got those ones before. So for velocity, it is Lt to the power negative 1. Divide that by the dimensions of time, which is t. So our answer here is going to become Lt to the power negative 2. And those are the dimensions of acceleration. Looking at the dimensions of force, we know that force is going to be the dimensions of force. We have its mass, multiply that by acceleration. So what are the dimensions of mass? Mass is capital M. Multiply that by acceleration. Now we already got for acceleration. Acceleration is Lt to the power negative 2. So times Lt to the power negative 2. So the dimensions for force therefore are M Lt to the power negative 2. So that simply means that this is how force relates with the three fundamental quantities. Now what we have been doing is what we call dimensions of a physical quantity. And we say that these dimensions of a physical quantity simply serve to show how a physical quantity relates to the fundamental quantities of mass, length, and time. And what we have been dealing with here, we've been looking at a few derived quantities such as acceleration, force, we've looked at volume, area, and velocity. All these are derived quantities. And what we've been doing in this video, we have been showing how these derived quantities are related to the fundamental quantities, the fundamental physical quantities, which are mass, length, and time. In a nutshell, we use dimensions of physical quantities also to check for the consistency of equations, and we also use them to derive equations. In our next video, we shall be diving more into this phenomena. Thanks for tuning in. This has been Arnold Rwangakuramya for Kisembo Academy.